So in this video, we're going to do the different calculations and how to do the problems. So to calculate the energy needed to heat a substance a few degrees, you would need to use the formula Q equals mc delta T. So the Q means heat, the M is the mass, the C is the capacity, and we'll talk about that later in the video, and the delta T is the change in temperature. So in this certain equation, this certain thing, the energy is going into whatever object you're heating up or whatever substance you're heating up. So for example, let's use a cup of tea. So a cup of tea is 120 grams. It heats from 21 degrees Celsius to 70 degrees Celsius. So our problem would look like Q equals 120, because 120 is the mass, and 4.184, because this is the heat capacity of liquid water. So whenever you had the heat capacity, it would either be heat capacity of liquid water or solid water. So since the T is liquid, we would use 4.184. So that would be part of our problem. And then the change in temperature is 49, because the equation to find the change in temperature would be, so you'd use, this is what the equation would look like. So it'd be delta T equals final, so that's F for final, minus initial. So for this certain problem, it would read change of temperature equals 70 minus 21. So when you do the math, it would be 49. 120 times 4.184 times 49 would equal 205.016. Certain problem, this graph, if you drew a graph, it would be going up, and it would be a slope because it's a change in temperature, because you're using the heat capacity. When you use heat capacity, the temperature goes up and it changes. So since the temperature increased in this problem, the slope would be going up. For when you calculate the energy needed to decrease the temperature of a substance, you would use the same formula. So it'd be Q equals mc delta T. So change in temperature would be negative 55. So the change in temperature equals final minus initial. So it would look like this. So it would look 20 minus 75. So 20 minus 75 is negative 55. So when you solve the problem, you go 140 times 4.184 times 55, negative 55. So your problem would read Q equals negative 32216.8 joules, because this is grams. This is the 4.184 is grams slash joules. So you would turn it into the problem was joules. Calculate the energy needed to change a phase. You would use the formula Q equals mH. The M stands for mass, again, and the H stands for heat. This equation is the flat part of the graph, so this is the phase part. So the other equations were the slope, but this equation is the flat part. You use this equation for heat fusion or heat vaporization. So, for example, let's do a bag full of ice, so 480 grams. Let's just say that's how much our bag, or that's the quantity of our bag, at 0.0 degrees Celsius, melted to water. So the bag would become 2/3 water. So our equation would read 2/3 times 450. So actually these would switch around. So it should actually read 450 times 2/3 equals Q. So when we do this equation, so 450 times 2/3 equals 300. So Q equals 300.